Now, let's look at this though, because we got to talk about a couple of things. Right here, right? What kind of graph does this group have? A linear, right? But guys, what did we just talk about with this equation? What do we see in this equation? An exponent. Not just any old exponent. The exponent is a variable. Because remember, this exponent, that's different. And we're going to try to talk more about that today. But this has a variable exponent. So we called this what type of function? Exponential. Hey guys, remember when I asked y'all to write equations, right? What was the first thing I told you to do when you were trying to write the equation? Try to what? You had to identify the type of function and then the what? Formula, right? Identify the type of function, then the formula. You know what we're going to do to try to graph this? Identify the type of function and then the formula. This is what type of function? Exponential, thank you. Okay. Now, if you need to, you can rewrite this, but we always want to notice what the b was happening to the b, what's happening to the a. Like when I say b raised to the x, what is that called again? Because that's going to, first off, what is b in this problem? But I mean, like, what is the b value here?
2. Oh, 1/3.
I mean, the b is second here, right? But notice, does this have the variable of x? No. So what is b?
1/3.
What is a?
2.
Now I want to remind you, so what were you about to say? You're about to talk about a y something, right? Y-intercept. Hey guys, how many times does a y-intercept happen? It only happens once. Notice how this 2 is just a 2. There's no variable with it or anything like that. That's the y-intercept. It's happening once. So if I were to make a graph, hey, guess what point I'm going to have? 2. Specifically, to me, 0, 2. Because if we talk about a y-intercept, what's the x value? What's the input for every y-intercept that has and will ever exist? The input is 0, right? I can literally see this is an x of -1 and this is an x of 1. And what's in between negatives and positives?
0.
That input is a 0 right here. Okay. So I've got 0, 2. I'm going to erase this a little bit right here just so I can extend in both directions. I always recommend that. Alright, so we have a 2. And what is this 1/3? It's a constant what? Factor. Jordan, what do we do with constant factors? We repeatedly multiply them, right? So what can I do to this 2 right here? Multiply it by what?
1/3.
So the next value is, someone said, hey Mr. Kinney, how do I multiply by a fraction? Well, 1, you have calculators. But 2, watch this. This is why I like fractions. What's 2 times 1? 2 times 1? 2! 2 times 1 is 2. And then what's this fraction bar mean? Divided by, so I'm dividing by
3.
3. If I want to get to the next value, what am I going to do to that 2/3? Multiply by what? By 1/3?
1/3.
And what's 2 times 1?
2.
And what's 3 times 3?
9.
That's why fractions are awesome. It's that simple. You multiply the numerators and you multiply the denominators. That's how you multiply a fraction. But also, hey guys, we got calculators. You can use them. That's okay. However, okay, I will point this out. I now want to go backwards some. Anyone know what I'm going to do to go backwards some? Oh, divide by? Divide by what? 1/3. And I understand how reciprocals work. So instead of dividing by 1/3 to go backwards, I'm just going to multiply by 3. Isn't this a division right here? What's the inverse of division? So if I'm going to go backwards, I'm just going to multiply by 3. What's 2 times 3? Notice I had to go backwards in the x. So I'm going to multiply by 3 again, and I get what? 18. Can I graph that? I have individual points. Can I graph those points now?
Yeah.
So I'm going to show you something else in a second. I want us to pick up on this next detail because this is figuring out a table and a graph by understanding the equation. And if you can understand the equation, you with me, Thrasher? You good? Okay. If you can understand the equation, a lot of this is really easy. But there's another way that will always work. Something we've talked about in the past. But really quickly, I have these points. Make sure you know how to graph points. And I can't easily do the 18 unless I scale my axis. I could, but I'm just going to leave it as is. So I'm going to go to negative 1, 6. 1, 2, 3, 4, 5, 6. There's negative 1, 6. 1 maps to 2/3. So an input of 1 has an output of? Good job, 2/3. Notice how it's a little bit less than 1. What does 2 map to? 2/9. And so 2/9 is actually pretty close to 0. It's not exact. But notice, does that give me that nice exponential curve that I've been expecting to see?
Yeah.
100%. Now, what questions do you have about how I used my y-intercept and my constant factor to get my table and my graph? Once again, I identified my type of function. I knew it was exponential. I wrote out that equation so I could find my y-intercept and my constant factor. That's what we've been doing. What questions do you have? At this point then, I want to pause and I want to point something out. Because there's a way that everybody, let me say that again, everybody could have easily done this. What do I keep using, what word do I keep using for these x values right here? Inputs, right? I keep calling them inputs. And so if I were to substitute 0 in, what's that 0 taking the place of? Say it louder. X, right? So what's going to happen to this x right here? I'm going to substitute 0 in. And hopefully you know how to do that. And if you don't, guess what you have in your hands? A calculator. Okay. By the way, I hope everyone brought their calculators back. I still got 4 hats up here.
I still got mine.
Okay. If you borrow the calculator, get it out. Put a hat on it. I need to make sure we have all our calculators. But look. 1/3 to the 0. Anybody know what that is? If we're not sure, how about everybody get a calculator in hand and type 1/3 raised to the 0 into your calculator. Because weirdly enough, we still got technology in this classroom that can make our lives easy. Put parentheses around the 1/3 raised to the 0. 1/3 raised to the 0. Alright, for those of us who don't know how to type it in, 1, put parentheses. Then, type in 1, what does this fraction bar mean again? Divided by. Notice how I never say over, because over doesn't mean anything. Put parentheses, 1 divided by 3. Then go outside of those parentheses. Does anyone know what symbol allows me to do any exponent? Say again? The caret, right? There's a little caret symbol right next to the x squared. It's called a caret. It'll allow you to do any exponent. So where it says x squared, right next to it is a caret symbol. Type that in, raised to the 0. I'll come around and check, but if you did not get the value or did not know how to type it in, talk to the people next to you. Make sure you know how to type an exponent into these calculators. Well, what are we substituting in? What are we substituting in, Thrasher? 0. Type it, hit enter then. So what do we get when we do 1/3 raised to the 0?
1.
1. And what's 1 times 2?
Two.
Wait. An input of 0 had an output of
Two.
2. Interesting. You mean the same thing as my y-intercept right here? Right? It's not a mystery, guys. The reason why that's my y-intercept is because an input of 0 gives me an output of 2. That's it. Now, m of 1. What's my input this time?
One.
Okay? So wherever there was an x, it's now a what?
One.
Hey, what's 1/3 to the first? 1/3 raised to the first.
1/3.
1/3. And what's 1/3 times 2? 1 is mapping to what?
2/3.
2/3. If you're not sure about it, why don't you type in 1/3 to the first and times 2? Type it in all together. That's okay. Just make sure you pay attention to your where your exponent is and everything else. I'm not joking. Type that into the calculator. Practice it. Practice helps a lot. Close. I don't actually have. Oh, because you did that. What I was saying is, I would type this all together to practice that. You said you can type it all as one expression. What? No way. You sure about that?
It did by itself.
Yeah. Hey, really quickly, I just realized I haven't shown all this, but this is one reason why I love these calculators and why they can be really helpful. So 1, you can quite literally type in 1/3 raised to the first and then times 2. See all that? Like I just wrote it, typed it all together, yeah? And then I hit enter. But let's say I also want, I don't know, an exponent of 2 because that's another input, isn't it? I can hit the up arrow on these calculators. And once that expression that I just did is highlighted and I hit enter, you see how it brings it down? And I'm just going to go in and change that 1 to a 2. Right? I just hit highlight it, hit enter, brought it down, change that exponent to a 2, and what do I get now? 2/9. Notice you just changed the exponent. Move. Oh, I wouldn't delete the exponent completely. There you go. Now let's say I want an input of -1. I go up, I hit highlight it, I hit enter, I go over till I get to that exponent, make it a -1. And did 2 map to 2/9? Just like we see right here? 2 map to 2/9. What did -1 map to? 6. Same thing we see right here. So guys, you can use your calculators. As long as you understand inputs and outputs, you can always substitute an input in and get an output out. Create a table of inputs and outputs, x and y. And then you can graph those points. Or if you know how to get the graph first, you can do the graph first. But I need to be clear on this. I am expecting you to show me evidence that you understand how these functions work and how to create a table and a graph. You're going to have a calculator to help you do the work, but I'm expecting to see evidence. Not that you just typed an equation into a calculator. What questions does this provoke or thoughts do you have at this point? Anything where you're like, hey, why in the world does blank work? Or can you explain this further? Notice I'm having to say random things because I don't know what questions you have. What's up, Casey? Okay. Well, if I were you, I would probably take some notes on this sheet. I don't know, notes to my future forgetful self to help understand how this exponential works. What's up, Blake? Huh? I'm famous?
I don't know why.
Yeah? That's important. It never stops. When you start to look for these types of functions, linear especially, but exponential too, all through the ACT. Don't forget, don't just write down the steps and the stuff that's on the board. Write down the question, or write down the whys. Need to write anything down, Chris? You could do it on, so Casey's asking a good question. You could write this information down on the practice I just gave you. You could write it down on the check your understanding and Frere that you have, or the Frere with notes and check your understanding. It's your choice. It's your choice where you write it, but we need to have this information easily accessible so that we can study. You've been taking these notes, have any questions popped in our mind about why something works or anything like that? Let me ask y'all a question. Why in the world is 1/3 raised to the 0 1? Janai, you got any idea why it'd be 1? Calculator told us that, right? I hope that if nothing else by the end of this semester, one thing that you're going to start to do is ask why. Because things aren't random. There's a reason why. I'm just talking about the 1/3 raised to the 0. Why in the world would 1/3 raised to the 0 be 1? Gio, any ideas? What would y'all naturally have thought 1/3 raised to the 0 would be?
0.
You would have thought 0, right? So why is it 1? Okay, let's think about this then. And I'm covering this not to just talk, but because this is actually really helpful if you learn this idea. So if y'all can pay attention to this. Let's say that I have 2 to the first. What is 2 raised to the first?
2.
Is 2?
Wait,
Is it 2 or is it 4?
4.
Why don't we type 2 to the first into the calculator then?
It's 2.
Why would it be 2?
Because it's not multiplying no time. Because they do 2 to the second.
Okay, so if it's 2 to the second, what would it be?
2 times 2.
It would be 2 times 2?
2 to the first, it's 2.
So what is an exponent, guys?
Repeatable.
Repeated multiplication. Okay, now I want you to think about this. Right here. When I say 2 times 2, I'm supposed to be multiplying by what?
It's
Well, I'm supposed to be multiplying by what? 2 to the second, I'm supposed to be multiplying by 2. How many times? 2 times. How many times am I multiplying 2 right now, actually, though?
20.
Am I? How many times do you see the multiplication symbol?
1.
Oh. I only see it 1 time.
Oh,
I'm supposed to be multiplying by 2. How many times, though? 2. So, what's got to be right here so that I can multiply by 2 times?
another 2.
But if I do 2 times 2 times 2,
2 to the third.
that would be 8 and not 4. What's supposed to be right there so I can multiply? Look, let's do this. What is 2 to the second? Type that into the calculator. What is 2 to the second equal?
4.
It does equal 4? So it needs to be 4, right? So what needs to be right here so that when I multiply by 2 twice, I still get 4? What does it need? Okay? What's 0 times 2?
0.
Times 0, or times 2 again? 0. So I don't think 0 is going to work.
1.
Okay, what's 1 times 2?
2.
Times 2 again? 1 times 2 is 2. Times 2 again is?
4.
Okay? Well, let's say I do that same thing here. 2 to the first means I'm supposed to be multiplying by 2 how many times? 1 time. See how I'm multiplying by 2 1 time? And what's 1 times 2? 2. So does that work?
Yeah.
Yeah? So like same thing with 2 to the third. What am I starting with 2 to the third? I'm starting with a 1. And then what's happening?
And put 3
Just like this?
2.
Multiply 3 2s. So let's be specific with our language. Right? That positive exponent is telling me how many times to multiply by 2. Starting with what number? 1. Okay. So what about 2 to the 0? What do I start with?
0.
Do I? What have I started with every time up to here? I've always started with a what?
1.
And then how many times am I going to multiply by 2?
0.
None. So I'm just left with what?
1.
Just left with 1. Exponents start with a 1. And then we're multiplying by whatever the base is, however many times. That's why it's 2 to the 0 is 1. That's why 5 to the 0 is 5 to the 0. Any guesses? 1. 1/3 to the 0? 1. Because we're always starting with a 1. This also explains what's 2 to the negative 1. Yeah, you can definitely do 2 to the negative 1. What do you get? You got what? 1/2? Huh. What does this fraction bar again mean? Wait, so I have 1, then divided by 2. How many 2's?
1.
So if I do 2 to the negative 2, don't type it into a calculator. Let's think about it. Hold on, don't type it in, Mark. 2 to the negative 2. What's that going to start with? 1. And then what am I doing to that 1? Dividing by how many 2's? So we really need to rethink our language here. A positive whole exponent is repeated what? Multiplication. But what are those negative exponents? Repeated division. Always starting with a 1. That's why these things are happening. So that's why when we went backwards, right, when we went this way, we had to divide by 3. When I went the other way, I had to multiply by 3. Because it was the reciprocal, it was division. Does that help us understand why raising to the 0 is 1? We good with that idea? Any question? Tomorrow, remember today you were supposed to have a what? Demonstrate understanding. Third block came in looking like they had seen war, so I almost ended up giving them the demonstrate understanding again. I'm just going to go ahead and tell you the same thing that I told them. I gauged their feelings and I made the decision as they were walking into class that I was going to push that demonstrator to understanding to tomorrow, even though it was supposed to be yesterday, and I already pushed it back. However, they irritated me enough that I almost went ahead and gave it to them today. You know what they did that irritated me so much that I almost went ahead and gave them a demonstrated understanding? They didn't pay attention when I was trying to help them, and they didn't do any of the stuff I recommended, and they just kind of sat around and did nothing. Listen, I'm okay with struggle. I'm okay with us not getting it. I'm not okay with us doing nothing to try to get it. It's okay if we're struggling to get it. I'll account for that. I'll work with you. But I need you actively trying to learn and grow. And I need you, no matter what group you're in, to make sure that you're trying to make sense of it with other people. And I need you to make sure that the people in your group are trying to engage as well. Like, you are responsible for your own learning and everyone in your group's learning. Your education matters. I thoroughly believe that. And that's why I'm not going to be an easy teacher, but I'm going to bust my butt to give you the best education possible. And if you work for me, you're going to learn a lot, you're going to grow a lot, and you're going to be successful long term. But I need you to actively engage and try to learn. Because everybody can. I don't care what your background is, I don't care what struggles you've had in the past, I don't care if you think I'm wicked tough or anything, I promise you, you can all be successful. I'm here to help you be that way. So, we're going to move forward from here. One thing I'm going to do to help support you is after class, I'm going to do a quick Zoom thing where I record myself working through a few of these problems. And I'm going to write the work on my tablet, or my laptop, because I can do that. And I'm going to narrate and explain how I'm going through these things. And I'm going to upload that onto YouTube so that you can use it tonight to help you study for the demonstrated understanding. Not going to do every practice problem, but I am going to give you quite a few of them to help you learn and grow. Take advantage of that resource, please. Okay? Mar, can you make sure everyone gets one of these? Not other question, I know this. Y'all did not get a solution key that Mr. Hobby made yesterday. I don't know why I forgot to give these out, but here is a solution key. But it only has kind of the bare notes, bare minimum on there. And so that's why I'm going to record providing more information on these details. Okay, so you good? Now, what Mara is passing out is our next set of Frere and notes and check your understandings. Thrash, are you with us? Let me get us started on the next piece first. With this Frere, it is all about identifying different types of functions. And what are the two types of functions we have focused most heavily on up to this point? Exponential and linear. Those are the functions with what types of rates of change? Hey guys, what types of rates of change do those linear and exponential have? Constant additive and constant multiplicative. Call it a constant factor, right? Those are our constant rates of change. But what's the one type of function we have not done very much yet? Quadratics. Okay? So, today, Remember, I'm taking off this demonstrate
Excuse
understanding.
this interruption. The custodians have requested that the teachers on the 100 and 300 hallways place your trash cans in the hallway each day around this time for the remainder of the week. Thank you for your help with this.
Sounds good.
What's that we need?
400. So, we've got quadratic functions on the docket. And we're going to learn about these through the Gold Rush task. And so, just as a reminder, we've already looked at determining if a relation is a function, identifying the type of mathematical representation, and all these terms. This is on identifying functions. Hopefully, on this proficiency scale, you can mark yourself off and identify and say, I can do all of these things. The next part of this is, given any mathematical representation, I can determine if a relation is linear, exponential, quadratic, or none. We've done linear and exponential pretty heavily. This is the identifying functions one. Okay? Now we're moving into quadratics, which we already talked about quadratics last Friday with Dr. Johnson. We're going to move into it more heavily today. And we're talking about equivalence, and so all those terms there. So you need to think about, hey, what do I know and what do I not know? This assessment is not coming up yet, but this assessment on identifying types of functions will either be Thursday or at the absolute latest Friday. And I know you're like, Mr. Kinney, we'll have just done one on linear versus exponential. But remember, I delayed the linear versus exponential by 2 days. We cannot wait for forever. So that demonstrated understanding will be Thursday or Friday at the absolute latest. The one that's tomorrow is all about functions with constant rates of change. Being able to identify the slope in any representation. Identifying the constant factor in any representation. And then all of these key vocabulary words. And then the target section is creating 2 variable equations for linear and exponential functions, graphing linear and exponential, and developing tables for linear and exponential. So we need to be able to do those things, and that's where I'm also going to post that video. Don't forget, you got to check your understanding is out the wazoo. If you finish all these early, and you still want, hey, more practice, because you know you need to practice things, let me know. I'll develop more practice for you. But now, we're getting into the Gold Rush task. I need everybody locked in on this context. So Lucas, eyes up. Thrasher, AJ, kind of hard to learn if we got our heads down. Here's the Gold Rush. Well, first off, what do y'all know about the Gold Rush? California, okay? We got gold, thank you. So the Gold Rush was in California. What else do we know about the Gold Rush?
It wouldn't get stolen.
What?
It wouldn't get stolen.
People travel all across the world to go get.
Say that one more time, Kyle.
People travel all across the world to go.
Okay, so people travel all across the world, especially from the east coast of America all the way to the west coast of California. Come on, we gotta know some more about the Gold Rush. Anybody know when it was?
No.
It was the 1800s? Let me ask this question. Hey, quick question. What's that California football team? San Francisco?
1869. Wait, the 69.
It was the what?
49.
It was the 49ers, that's right, because the Gold Rush was in 1849-ish. Okay, there we go, right? Gold Rush, California, it's 1849. And you're pretty confident you're going to find gold, you can get rich, right? We want that money. You want that money, Gary? I want that money, right? I ain't getting that money, but I want that money. Anyways, so we're going across to California. We want to get some gold. And there's this man. This man, Dan Jackson, he was pretty smart. Dan Jackson, he's lazy, okay? But he's got money. And with that money, he bought some land. And he's renting that land out. And so you're going to rent some land from Dan Jackson. And when you rent land from Dan Jackson, you're going to get 4 stakes and 100 feet of rope. What's she doing over there? First off, you need a dungeon master for that. Second off, you need an actual story for that and a character.
I got it.
Okay, what's your story? Oh, okay. So, 100 feet of rope, and you're going to rope off your land. Now, when you rope off your land and you stop playing with dice, when you rope off your land, What's the best shape to use probably if we got 4 stakes and some rope? A square maybe, but in general,
Rhombus.
maybe a rhombus. So you're referring to what? Starts with a P? Parallelograms, right? What's probably the easiest types of parallelograms? Squares or what? What's the other one?
Rectangle.
Rectangles, right? So I'm going to recommend using a rectangle. All right? And so when you create this rectangle, you want the best chance to find gold, right? Yeah? What do we need when we create our rectangle for the best chance to find gold? The what? Say it, Christina. What'd you say? What'd you say? Okay, you do need something parallel. That's a rectangle. What? You need it to be what? Say it louder. Okay, maybe you do. But, I mean, we're just digging.
A shovel.
You guys, yeah. But, like, come on, think about your rectangle. Do you want this rectangle or do you want this rectangle?
I want big.
Oh, so what do you need to have the best chance to find gold? You need the biggest rectangle. Come on, let's use some mathematical language there. We need the biggest what?
Shape.
Say it again. Area. Right? We have the best chance to find gold. We need the biggest area. But hey guys, you only have how much rope? 100 feet of rope. Okay, so we got to be strategic with this. I can't just make it as large as I want. I only got 100 feet of rope. So let's just say, I make my height here 5 feet. What else do we know then about this rectangle?
The other side goes 5.
The other side's going to be what?
5.
All right. Anyone know anything else? You got to use the rest of that rope. So how much is the rest of this going to be? 40? Is that right?
Yeah. The other side is
Wait, what's 40 plus 40?
80.
80 plus 5 is 90. What were you saying, Christina? Oh, it needs to be 45. What does that add up to? 100. Remember, I want to use all 100 feet of my rope, right? In case we just said we wanted the largest what? Biggest what? Say it louder. Biggest what? Area, right? Hey guys, how are we going to calculate this area? So I will say this, I know most commonly we're used to length times width. What I'm going to recommend is just rephrase that as base times height. You've done triangles in the past, right? What's the area of a triangle? 1/2 times area of a triangle, guys.
What hell?
1/2, yeah, area of a triangle. 1/2 times. Oh no. Seriously? The area of a triangle. Hold on, hey guys, pause and listen. Listen, okay. We're doing a rectangle. We are. But I'm trying to help you understand why I would recommend base times height instead of length times width. The area of a triangle is 1/2 times base times height. The area of a parallelogram, just base times height. The volume of a prism, area of the base times the height. When we use base times height, that is a more accurate way to do it than length times width. I don't know why we teach length times width in elementary school, but we do. We need base times height. So that's what I'm going to use. So what's my base here? 45, what's my height? And so that area comes out to be 225 square feet. Now that's just one option. How likely do you think it is that that's my best option? Unlikely. Alright, now remember, we want to stay organized. We don't want to be random. What's another base that I could now try that might be a good idea? Or another height that I could try? Okay, so 10. So a height of 10. So what's my base now going to be? 40. And so now when I do base times height, I get 400 square feet. So at this point, which option do I want to go with? The 400. You see how by changing my base and my height, I got a bigger area? I want you to find the biggest area. What dimensions give you the best chance to find gold? The catch to this is you need at least 2 mathematical representations to justify your answer. Because remember, it's not just about finding the answer. What are we trying to discover through this task?
Gold,
Say again?
gold.
Gold. See, that's the answer. What are we trying to discover through this task? What type of function do we need to understand? This is all about quadratic functions. So, we're doing a task, and I need you to find the biggest area, the best dimensions for the biggest area. So let's get to our vertical surfaces, and let's try to find the biggest area. And he is actively collaborating together.
Kind of looking when you put it on this street. It's new. He was talking about.
That's handy for gold. But we're
You said it's 8. Oh, it's only.
digging. You're talking about it river.
It was on the board.
Think like Pocahontas where they're digging for gold.
8. You right here? Yeah.
We're not digging the sand, we're digging in the earth. We're trying to find a gold mine. We're trying to find a vein of gold. Let's go.
That's a key. What is the